Okay, so today, this is a quick rundown of JupyterLab, which is a Python notebook environment that you can run straight from your web browser. It is a little bit different if you've used other coding environments. I'm not gonna teach you how to use Python, but we will be using this from the consumer standpoint. Okay, and I'll show you how we can make it dance. So you don't need to understand everything about this tool. But if you parse through some of these short functions, you should be able to make sense of them just from your comfort level with math and logic at this point. Okay, so what you have when you click on this link is an Euler's method algorithm, and that starts here in the code. Okay, hashtag means that it's just a commented out, and then this is kind of the operation that's happening. And it's the exact algorithm that we do in class. Figure out what your step size is going to be. What's your initial starting conditions? And then what's the definition of your slope? So you got y prime on the left and f of xy on the right. That's going to go here. Okay, so where it says return this for this f of xy, when we go into our creating our table, it's going to be reading this as the right-hand side. Okay, so for here, this is 2x minus 2y minus e to the negative 4x. You need these times for multiplication, and this is how Python reads exponents. Okay, so it's the double asterisk instead of the caret. So when your right-hand side changes based on the exercise you're working on, you will update this part of the code, and then you'll simply run it. Everything else is set to go. It's set to have prompts. So you got to just make sure that this code is not running. So I hit the stop button, and then make sure you're selected in this block of the journal. That can be a problem too. If you're not selected, you hit play, it'll think you're in some other block. But hitting the play button, and then you should get these prompts for these inputs. It's reading this part of the code right now. It's going to ask you for the initial conditions. So here are initial conditions. Let's say we're starting at x equals 2. We know the y value starting was 1. We're interested in the prediction for when x equals 3, so we'll put in 3 here. And then we know our step size would be 0.05. And so then below it will spit out this table, x naught, y naught, the slope that was calculated, so f of x naught, y naught, and then the projected y sub n, which will then feed that back in through the algorithm each time, and then at the very end it will give you its prediction using Euler's method. Okay, so again, that's a couple things just to make sure this block is selected, program is stopped. You're going to update your function every time. This is the right hand side of your DE. This you don't really need to play with. It would be probably smart to read through it and make sense of it for seeing how this loop works, and then everything else just comes from the inputs here with your initial conditions and then your step size. All right, so this will be fun. This will give us some flexibility to play with for a tool. And if this, becomes too cumbersome, this can be a little bit glitchy at times. We'll just shoot over to spreadsheets. But I figure this is worth our time because this tool is used widely in research, used by data scientists. It's one of like the top 3 environments for using Python. And Python and R and things like this are what are being used right now. So why not play with the tools that are actually being used out there? All right, so have fun, and we'll see you next time.